Hi and welcome back to Digital Color Theory. I'm Lauren Meese. Hope you've had a good week. I've been enjoying the conversations back and forth on the forum. A lot of interesting things. I'm learning stuff too, which is good. That's why we're all here. Okay, for this week's class, we're going to talk about multiple secondary color correction, current and future technology, video standards, signal flow and patching, and legalizing the video signal. So, quick review. In last week's class, we talked about color interpretation, matching shots in the numerical interface, understanding secondary color correction with hue, saturation, and luminance, the correction workflow, stages of color correction, setting white, black, and adjusting your gray points numerically, and setting up your workspace. So let's talk about multiple secondary color correction. In a previous class, we were working on isolating and adjusting one color for enhancement on that hay bale, and then we went on to the sky. So just to reiterate, once an initial adjustment is made to the overall contrast and balance of a shot, the adjustment of secondary colors is the next in achieving the final look. This week we'll look at changing the color value of multiple colors in a scene, and if you want to change the color of a person's shirt or the color of the sky without changing anything else in the scene, this is how it's going to be done. This week's example will be the stained glass in behind the priest. See if we can adjust our focus so the priest will become the predominant area of focus on the screen. This shot needs some correction, so I'm going to go over to my bin, load up my color corrector, and off we go. First thing, I'm going to set my blacks, bring my blacks down just a little bit, bring the whites up a little bit, and then I'm going to have a look at the preacher's face, so I'll adjust the mid-range as well. I can see that the blacks have lifted a little bit, so I'm just going to go back and rebalance those. Pull the whites up a little bit. Okay, maybe a little bit of saturation. Okay, I have the shot looking the way that I'm happy with it. So next thing I'm going to do is the producer comes in and they said, you know, Lauren, the color of the stained glass looks too bright compared to the preacher's face. Is there any way you can mute that down? No problem. I'm going to take a color corrector that has no parameters loaded in it. I'm going to put that onto the timeline, and I'm also going to do a red one as well. So when I come over and look at the numeric display, there I've got blue and red. So I can hit the blue one now. I'm going to sample the blue pixels in there. I'll switch over to the matte view now. Start to adjust the key level, selecting the different parameters. These types of images are really good to practice your secondary color correction on because they're so saturated and easy to do a color key on. They work really well. So get a rough look out of this. Now I can go through and just bring the saturation down, and I can also bring the luminance down. And yes, I haven't qualified every shade of that color, but sometimes it's easier to see it in color mode than it would be than just looking at it with the matte view. So there, that's looking pretty good, and I can turn that on and off, so I'm affecting that. I'm not touching any of the red, just the blue right now. And then I'll go through and, just for fun, I'll play around with the red. So go through to the red, and I'll do the same thing. Sample the red, And the other thing that you'll have to do is watch these pictures in motion, because what you find is if you go through and you adjust all these, you get the color key just perfect. If you watch it in motion, sometimes you'll have a different effect. Maybe you'll be tearing a little more or a little less. So sometimes it's easier just to, get a rough key on it, and then go through and render it off and play it and see if you see any tearing in there. It's a toughie. Okay. Now I maintain good control of the session because I've got my primary color corrector. I'm going to set the balance on the shot first, and then I'm going to go for the secondaries. And if I look over here, maybe I want to put I've got to put a broadcast safe on there as well. There's the broadcast safe. And that's going to bring that back down to where I want that. Maybe just put that up a little bit. Okay, and there's your finished shot. So last week I talked about setting up desktop so that you can just jump into the chair and get into the zen of color correction. I can't think of a better word to call it, but just clearing your head of all the daily things that are going on, and what you need to do is to be able to adjust the images that you see on that screen and put everything else out of your mind. So I like to have folders set up with all the different color correctors. In this case, I've got a display of Final Cut Pro, but it could be setting up your memories in DaVinci with all your different task settings, or if you have different looks that you want to preset, get that all organized before your customer even shows up, so you can sit down and you're both exchanging pleasantries, and then you're into the business of getting those images to look the way the producer wants. So here's my list of different filters that I would use in, say, Final Cut, and I'll get into that in just a moment. I also set up what I call a scratch pad memory. So if I'm running down the timeline and I find a shot that has a really neat look to it, that I've applied a certain color correction to it that's really outstanding, and I think, gee, I want to keep that for use on another project, I'll set up a bin and I can just pull that color corrector down into that bin, and while I'm trying to stay organized working on the project, I am thinking one project ahead maybe, but I have a place where I can put all my special corrections, and it's already named before the session even begins, so I'm just able to drag that down. So the way that I've built up this folder, I'll go over to my favorites folder, and I've preloaded everything. So these are just blank filters that I've renamed. So this color corrector, if I click on this and activate it, it's just a color corrector with all the numbers zeroed out. I've taken that and renamed it, and I name it in DOS format so that I have everything in the correct order. So I have red, blue, green, yellow, magenta, cyan, spare one. I've got the broadcast safe legalizer here, Gaussian blur, luma keys, mask shapes and feathers are all there. And I just find it's better than having to dig through however many folders you have here for the correct filter you need. It's just going to make you look that much more organized that you have all your stuff right here. Now I'm also going to set up a bin which I'll call Color Scratch Pad Memories. You can call it anything else you want. And what I'll do there is if I see a grade on this shot and I go, ooh, that's really nice, and maybe I'll use that down the road, what I can do is, let me just go over and find that color corrector. There's my color corrector. I'll just pull that down. I have that bin already named. I'm going to pop that right in there, and I'll say church grade. And I've got that saved, so I'll know if I want to come back to that in 2 sessions from now on another project. I'll have that saved, but I have this bin already named and ready to go. Now I can just click back and I'm doing color correction again. So just a fast way to make yourself look more organized, and you're concentrating more on the picture on the screen than you are playing around with the menus. And this can be done in all the different color correction softwares as well. They may have their own idiosyncrasies of how you do it, but there's the workflow to keep yourself prepared. Now, John Logie-Beard was a Scottish engineer. He's generally credited with being the first person to produce a discernible image on a television screen as early as October 30th, 1925, and went on to produce other advances in the field. Baird's mechanical television system was replaced by the electronic television system described by Philo Farnsworth and Vladimir Zworykin. And what we ended up with is 3 systems used worldwide: NTSC, National Television Systems Committee; PAL, Phase Alteration by Line; and SECAM, Système Électronique Couleur avec Mémoire. For NTSC, this is an interlace system, as you know, 30 frames a second, 525 vertical lines of resolution. In PAL, that system, 625 lines, again interlaced. And the SECAM system, again interlaced, 625 lines. I'm sure if you were doing a commercial for a makeup or a paint company where specific colors had to be reproduced, there's enough difference in color between NTSC and PAL that you would need to do a specific color correction for images shared between PAL, SECAM, and NTSC, or vice versa. In North America, monitors use a SMPTE Type C phosphor in the construction of the tubes, and PAL uses an EBU type phosphor, which dictates the colors that those monitors can reproduce. You can do some research into this yourself and see the differences. Charles Poynton has a great website. When HD came about, do you think this got any less confusing? Well, not really. There's a noticeable difference between a high-definition video signal and their standard definition counterparts. Digital cinema is the same story. There are a number of color management systems out there to help do a conversion, such as Thomson's Luther. This system does a good job anticipating where the color belongs, but humans make the best judgment on this. Is there a way around this issue? Well, educating yourself and your clients are one part. Know where your program will be broadcast and watch it in that format is a good rule of thumb. The film and television industry has no control over the development in the technology it uses. You just have to look to the stars if you want to see what's coming. The new model is to be as cost efficient as possible, do more with less. Our industry works with expensive equipment, and the skilled technicians that are needed to run the equipment aren't cheap either. The industry is looking to reduce costs. You can see this with a decline of film usage. There's nothing better to capture images than film, but with digital coming along so quickly, there's great competition. The use of digital reduces your costs if used properly and leaves more room for profits. Viewers are looking for a real-world experience through their television set or when they go to a theater. The better we'll be able to bring them a more photorealistic image and better sound, the happier they'll be. Digital cinema has gone a long way to increase the quality of the image we see and the cost to produce them. This system can take advantage of increased resolution and color bit depth that's captured on the newest film stocks. Digital camera technology has greatly improved in recent years with the buzz around the RED and DALSA, for instance. The use of the expanded XYZ color space with 12 bits per channel are very close to the limit of our human visual system, thus producing amazing pictures. Higher resolution and increased color space of the new cameras are great. How do we store these images for post-production? Videotape is the cheapest and best removable storage medium we have so far. As we move into digital storage, there's been an increase in choices with removable storage devices. DVDs, memory cards, and small hard drives will become more popular. The technology will have to improve to the point where you can store at least 30 minutes of uncompressed media on these drives, cheaper than you could on videotape, for them to be popular. InPhase Technology, an offshoot of the Bell Labs, has the first commercial holographic data recorder. This device holds 100 gigs of data on a single CD-size write-once disk as a succession of 1.3 megabyte holograms. That's enough for 30 minutes of uncompressed high-resolution video. We'll see how this is applied to the film and the television industry when it comes to market. At this year's NAB and IBC, more choices than ever will be available for film and television color correction. As long as you have a grounding in color theory, you'll be ready for the new wave in technology. I'm working on a shot here, and I've noticed something, that when this couple comes into the hallway, they're really dark at the back, and they're very hard to see, just some side light hitting them. And as they move forward into the light, they started to get a little bit brighter. Now, what I'd like to do is be able to see them down at the beginning a little bit better. So I'll back them up at the beginning, but if I put my color corrector on here, and I have my color corrector ready to go, and I lighten that up so I can see them a little bit better. As they walk forward through the shot, they're going to be too bright. Like even there, they're too bright. So one thing I can keyframe this shot and bring the brightness level down. But what I'd like to do is I use a cross dissolve, which I find is it's the same as the one you'd find in DaVinci or the other tools, but this is how you'd use it. So I want to be at the normal brightness at this time code 1303. So I already have the color corrector on the shot, so I'm going to figure out how I can transition. So I'm going to hide my transition with some movement. So I'll pick, as they start to move forward, as the point that I'm going to start to change the brightness back to normal. So I'm going to just cut this shot in half. So I'll enter a mark in my EDL. I'll highlight this, and I'll tell the system that I want to make it a cross dissolve. But I'm not crossing from one piece of media to another. I'm crossfading between one color correction to another. So I want it to start right at the cut point. So I'm going to change its orientation, so it's going to start over here where I razor bladed it instead of halfway into the next shot. And I'm going to make it kind of long, so it's really very subtle. And the best color corrections are the ones that you don't see. So now I'll go back to this side, pick my color corrector, and I'll bring the brightness back down to where it was in the first place. Then I'll back the shot up, and we'll see it's kind of bright there. Now I can see that, so I've got to adjust my time. Maybe I want to make that 4 seconds. Back it up again, and as they cut through the light, they're going to help hide the fact that the brightness is being changed. And there you go. Now I like using this because if you go with the keyframes, you have to mark out all the points, and I just find they're difficult to edit all these key points. If you want to, you get into a room full of your clients and you want to start changing everything around, they may want to start something a little earlier, a little later. With the cross dissolve, you double click on that, you change your time, and you can slide these back and forth. I find it's just an easier way to do it. So, the day for night look. In order to film your scene, you need to illuminate it with light. An important element to filming is an understanding of light and its properties. You need to light the scene you're filming, compositing, or developing. The creative use of lighting goes a long way in helping tell your story. I'm in a grading session, and the associate producer has told me that the scene connected with this shot has to be graded as if it were nighttime. The crew wasn't able to film this scene at the correct time of day, but it didn't matter. According to the script, it had to look as if it were nighttime for the scene to make sense. In the film and television industries, you don't always get to choose what time of day an image is filmed. Here's some reasons for shooting a night scene during daylight hours. The show may have a crew contracted to shoot daylight hours only. There's no budget for the added expense of lighting and generators. There's added safety issues when you shoot at night, and the locations that are available in the daytime may not be available at night due to possible noise issue in the neighborhoods. Let's look into the theory of how we get this shot to look like it were filmed at night. I'm going to critically analyze this image and ask myself, what is the source of illumination for this shot? What's the quality of light or color temperature of that light? Is the light incandescent, fluorescent, or daylight? And what direction is the light coming from? What angle is the light source coming from as well? Is the source of illumination direct or indirect? When we film a scene for television or a feature, the camera requires a certain amount of light to expose the image. The weather, should we decide to shoot outdoors, may not cooperate and give us consistent light in the qualities we wish to film with. Half our shoot could be made on a sunny day and the other half done on a cloudy day. When the shots are edited together, they don't look as if they were shot in the same time period. Lighting and using the properties of light help overcome the inconsistencies of natural light and enhance the situation for our shooting purposes. What is light? A wave. What are the properties of the light? Light is visible and contains colors. How do you reproduce the properties? Select the light sources that best imitate the quality of light you want to reproduce. For example, a fire. Get a source that has the properties of red, yellow, and orange light, that flickers and is diffuse. Waves from a source are emitted and bounced off an object and relay certain information about that object to our eyes and ears. We'll get into this in a minute. There are two different lighting conditions that affect the way we see color: photopic, where light is plentiful, and scotopic, where light is scarce. Now, photopic vision is under well-lit condition. Our eyes use cones as primary receptors, and we'll be able to see lots of color information. Scotopic vision, or night vision, uses rods as our primary receptors. We aren't able to see a lot of color information. And you can use the example of looking at a cedar hedge during the daytime. It's nice and green, you can see lots of detail, but at night that hedge appears black, and you know it's not black. And partly to do with the amount of light hitting it, and also the fact that at nighttime we're using our rods to see the hedge, so we end up with a more monochromatic image. So if you're doing day for night, to mimic scotopic vision, you're going to be more monochromatic. From looking at this scene, I've observed the following. The light source is sunlight. The color temperature is around 6,500 degrees Kelvin. Light bends as it travels around objects. and it'll be difficult to key the sky as it transitions around the roof line. The light source is incandescent from the sun. The primary light source is coming from the right side of the frame. The sun is around the 2 o'clock position, and the sunlight is direct, and there is bounce light reflecting off the brick wall. Make sure you ask what the final destination of your work will be, whether it's video, film, internet, or print. You want to know what bit depth and what color parameters that you're working on. Okay, what video controls do you need to get the job done? That's what we're going to get into. First, we want to know that before you begin, that your monitor is correctly aligned. And how do you begin the process? Firstly, I notice with the scope package turned on that the blacks are green. I'm going to rebalance these and put them to about 10 units and add a Gaussian blur to help reduce the contrast in the shadows around these actors. And you can see we've got some pretty heavy shadows around the actors here. The light hitting this scene is very directional, and at night the light source will come from a number of sources and be of softer value. When the sun goes down, the color temperature of our world changes as the sunlight isn't going through the atmosphere, the thick part of the atmosphere anymore. If you have a moon, the ambient moonlight will be around 6,500 degrees Kelvin. Have a look at the moon and you'll see what I mean. Nighttime is an absence of red, not an increase in blue. The blue comes from working on systems that in order to lower the red signal, they overpower the screen with blue. With this example, there's a lot of red in these bricks, and we'll have to reduce this to make it look real. Look out in the parking lot when you go home tonight, and you'll see what I mean. Next, I'm going to rebalance those blacks again, make them nice and even, because shadows are black. The light sources for the scene are coming from a few different places. It will be directional, and so there won't be anywhere near the amount of fill light that you have here. To account for this, I'll bring down the master gain. Nighttime isn't dark, it's just a lack of fill light. The light could be coming from the moon, the gas light that's up here, or maybe even a car headlight, or some of these windows along the walls here. Lower the gamma control, the mid-range control. Now we're going to try and make this image look really contrasty. When you do that, you'll see that the saturation stayed where it was before, so we'll have to lower that down so it doesn't look as cartoony. And this should take care of the basics. And now we can get into the more creative aspects of day for night. The next stage is secondary color correction. Let's get after this sky. The sky in this shot is a dead giveaway that it's a daytime shot. And what I'll do is I'll sample the blue in the sky and lower its saturation and see what we can do. See if we can make this more believable. Okay, sampling the blue and reducing its saturation helps. The only thing here is that the sky is bright at the bottom and dark at the top. Again, still doesn't look quite believable. I mean, it's getting there, but we still can try a couple other things. If the associate producer can give you some extra time as you've cruised through this shot quickly, you can work some of your magic. Cutting a matte for the sky and replacing it with stars, that's one thing you could do. Have a look at the roof line and you'll see what I mean about light bending around the roof. You'll have to do a soft edge around the roof to bring down the spill. So right in along here you can see the light as it's going to bend around the roof line here. Now you could even mat out the different parts of the wall and bring the brightness down, adding lights in the different windows. The brightness of the lights should fall off as they go towards the background, and remember your color balances, that you might have a tungsten light in this room, maybe a fluorescent light in this room, maybe a television set which is putting out some blue down here, but you should go from light down to dark in that order. Because this scene was filmed in bright light, it has a large depth of field. The frame is mostly in focus from front to back. To help with the realism, you need to make what you put in the sky slightly out of focus to draw the viewer's attention to the foreground. So you can see here, you can see every single star. If you were standing in the foreground looking at this scene, you know, all down here would be out of focus, would be a softer focus, the same up at the sky, with this foreground in focus. So remember your depth cues. Depth of field, the definition, how much the image is in focus from foreground to background. More depth of field is more area behind the subject is in focus, and less depth of field, the less area behind the subject is in focus. A central equipment room is a space that houses the video and computer gear for a post-production facility. It's usually a secure room with environmental controls to prolong the life and help in the maintenance aspects of all the equipment. All aspects of recording, playback, and distribution are handled through an equipment room. Video patch bays are used to connect all signals that route through a broadcast facility, just like the old-style telephone switchboards. Each video device in a facility can have over 24 cables connected to it: video, audio, timecode, and control signals. The panels are usually set up in such a way that allow normal operation of the facility without changing anything. However, quite often studios and other areas may require signals to be routed in a non-standard manner. For example, this may include sending signals to a temporary workstation, rental VTR, or a special monitor for a client in the edit suite. Even in facilities which have video routers, not all signals may be available, as it's not cost-effective or worthwhile to put the hundreds of available video signals there. The video patch panels also allow signals to be rerouted if there's an equipment failure, and they show signals going into and out of the router to allow for manual override if it's necessary. Video signals, which are usually permanently fed, such as those in and out of a router, are connected using a small connecting device called video jacks, examples of which you see here. They come in varying sizes to suit the different patch panels. Patch fields for standard definition may not be able to handle the high frequencies required for high definition signals. Analog component signals require special cables to carry the Y, R-Y, and B-Y timed signals. You'll find quite a number of these patch panels in equipment rooms and other areas. Most of these feed crucial systems such as routers, monitoring, and reference feeds. Before you touch anything on a video patch panel, you should always think, who else will be using this signal you're about to unplug? And, is there somewhere else you can get it from without unplugging a video jack or existing cable? Most of the signals that you're likely to need are available on spare outputs on the video jack field. All these patches are a push-fit connection, allowing for fast and easy connection to video signals. The way signals are set up for their default use is called normaling. On the video patch bay, the video jacks are used to do this process. They connect the top socket into the bottom socket, and so allowing the signal to pass through. The standard way that both video and audio patch panels are set up work in the same process. Patch bays work in horizontal lines, which are usually in pairs, as in this picture. The top row is an output and the bottom row is an input. So for an example, an Inferno output might be on the top row and its input to the router would be on the bottom row. A video patch is then used to connect these two together, but can be removed if really required. A router source, such as this, should never be removed, if not in extreme circumstance. Consult the engineering department if you feel the need to do so, as someone else might be using it. I'm starting color correction on this show, and I have my ideas of the way that I want it to look. You know, these two people are in front of a window, and I want to make the images very hot, so I painted a picture like this. Now I'm going to have a look at the technical specifications for this show from the network, because at the end of the day we have to sell these images to somebody. That's what we're here for. So looking at their tech specs, they're telling me that video has to be so many IRE units, or so many millivolts. So if I have a look at my scopes, the picture that I've actually painted is way above 100, and the chroma is off the dial, but I happen to like it. That's the look that I want. And I have a couple of choices here. I could either bring that level down, which I'm sure is going to change the whole look of the show. It's going to make it not as snappy. So that's affecting my subjective way that I paint the picture. Or most systems, let me put it back up to where it was. Most systems that you work on nowadays, the pro systems like a DaVinci, Lustre, IQ, those type boxes, will have a clipper in there to make you broadcast safe on the way out. What you don't want to do is put color correction in the hands of technicians at the network who are not familiar with your color correction. They have no idea what you're trying to do, what you're trying to say with your contrast, brightness, and saturation of a shot. What they're going to do is, similar to this, I'll just click this broadcast safe filter on and off, and that's what they're going to do is, you can see in here, if you were doing a product shot, again, you know, the highest quality level for makeup or paint or a car commercial, if you sent your picture out looking like this and you got it back looking like that, your client is going to be pretty upset with you, because they said, well, listen, you sold me this look, and what I got back when I watched it at home was that, and that's not the same. So the choice is, either you run with your broadcast safe or clipper turned on, or you bring the brightness and saturation down and paint your images against that backstop. Now, a couple of things that I've done here is, I've chosen to clip this information off. You can see all these pixels are bunched together up at 100, so I've lost a fair amount of detail here. You can see it in the scopes that it's you know, mostly the red and blue channel, and not so much in the green. But this is the picture that I've chosen to paint. The other thing I'm going to have a look at is the chroma, and chroma is way off the dial. You shouldn't have chroma going beyond the center of the target. So if I were to put up a color bar here, you wouldn't want to be along. The color bars would appear, they're the vector for each bar in the center of these targets, so you wouldn't really want to be beyond that. So again, what's going to happen is, you can see red is way beyond. Let me just turn the brightness off so you can see that a little bit better. There you can see red is way off the dial. So when you put that through a broadcast safe clipper, chances are that's going to be cut to black. And I'll just turn this on in chroma so you can see here. So we've got like a lot of color information. So again, I have the choice of adjusting this broadcast safe filter, my backstop, to bring that down, and I'll even see if I can bring that down. It brings it down somewhat, but it's changing the color around. So you can it's best to run with this, but just to back off on the saturation a little bit, and that way you stay in total control. So once you've timed the picture and you've sent that off, there shouldn't be any more processing. You need to check that yourself just to make sure that you're well within your limits, you've checked your tech specs, because if you send that off to the network, they're going to reject it and send that back, and that's going to cost you money to have that shot color corrected again. As far as visual effects shots, that's a whole different ball game, because if you're doing an effects shot, you have to be aware of your color palette again. If you're doing a shot and you're going to hand that off to another colorist, if you want the colors to look as if you just made them, like that's your shot right there, you hand that off to the finishing colorist. They know, the finishing colorist knows that they'll have to apply a broadcast safe to that, and if your colors are way beyond the specs on the scope here, they're going to either clip them or limit them, or it's going to cause some sort of problem. So you need to be aware of these as you comp shots together and you're adding color elements to a shot, that you don't go beyond the spec limits of the show, and that way your pictures will look that much better, because you're in total control of that. As you hand that off to the finishing colorist, chances are they might just do a little balance on that, and then off it goes. But stay in control and make sure you double check your scopes to make sure that you're legal. Lauren's picks this week for DVDs for color correction and visual effects. I've got 3 good ones for day for night. Castaway has a bunch of features at the end of the DVD that are quite interesting. Hunt for Red October is the next one, and Perfect Storm, great films with day for night. For next week's class, we'll talk about the history of recording, color correction workflow, film basics by the numbers, and some spot color correction. Boy, time flies. Thanks for watching this week, and we'll see you Class 7 next time.